Hello everyone. Since we are tasked to create a 6 by 8 sparse matrix, let's have this table. So 6 by 8 table. So 6 times 8 is equal to 48. So we have 48 elements in our sparse matrix. So let me first tell you what is a sparse matrix. So sparse matrix contains null or zero values. Here, notice that in a sparse matrix there's a lot of zeros. So, for example, on our memory spaces wherein you use a table and some values have no use. So, here we'll notice that these zeros have no value in our sparse matrix. So it is just a waste of our memory space. So what sparse matrix do is to create another table based on the sparse and remove the non-zero values. So sparse matrix do is to copy these values to another table wherein the zeros are not included and only non-zeros. So in our sparse matrix, we have how many elements? So number of elements. If I say number of elements, the non-zero values in our table. So let's count our values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So we have 13 number of elements or non-zero values in our table. So now, since I have mentioned that Sparse will make another table to delete the zero values and to remain the non-zero value. So it will depend on you on how you will read it, by row or by column. So for me, I'll read it by column. So we'll now create a 3-table row where we have column, row, and value. So it depends on your implementation. It's either you'll use a row major or a column major implementation. So let's start now. So first, our non-zero is in our column 0 and row 0. So column 0 and row 0, we have a value of 2. And next non-zero element is located here in our column 5 and row 0. Column 5 and row 0, where we have a value of 4. So next non-zero is here. It is located in our column 2 and row 1. Column 2 and row 1, where we have a value of 6. So let's proceed. Next, another non-zero element here in our column 4 and row 1. Column 4 and row 1, we have a value of 8. So next here, we have 10 in column 3 and row 2. Column 3 and row 2, we have a value of 10. So next, we have here in our column 0 and row 3, column 0 and row 3, we have 12. And next, in our column 2 and row 3, column 2 and row 3, we have 14 as our non-zero value. And next, we have here, we have it in column 4 and row 3. Column 4 and row 3, we have 16. And next here, we have 18. 18 is located in our column 2 and row 4. Column 2 and row 4, we have 18. And next, on our column 3 and row 4, we have 20. Column 3 and row 4, we have 20. So next, we have column 1 and row 5. Column 1 and row 5, we have what value? Column 1 and row 5, we have 22. And next here, on our column 5 and row 6, we have 24. Column 5 and row 6, we have 24. And lastly, we have in column 1 and row 7, 26. Column 1 and row 7, we have 26. So now notice that we have our 13 non-zero values and their exact locations where they are located. So in our column 0 and row 0, we have value of 2. In column 5 and 0, we have 4. Column 5 and 0, we have 4. So here it is. So let's fill this so that we'll have to, will not complicate things. So there it is. Next, we'll have to create a code to implement this parse matrix and to see how it runs in our code. So now we will create our program code. So now we have our program code here. So here in this first code, we only implemented or create a program for us to store values inside our array. So since this is a two-dimensional array, we have the first for loop here and the second for loop here. So let me just try to run this code to see what will happen in this first program of ours. So here it says here that we should enter array values. Let's say I will input a value here. So what happened is that we have an input 2 as our value, and if we press enter, then I is incremented now, wherein if we enter this, it will proceed to our next value. So let's try to simulate this code, wherein let's put 0, since this is our column and this is our row. So in column 0, wherein our value is 2, column 0 and row 0, we have a value of 2. So next, since I is incremented, it will become 1 now, and we'll have to input a value here inside. So 0 is our value inside column 1 and row 0. Column 1 and row 0. So we have 0 here. So since the condition is still true, then we'll move to our next value. I again will be incremented. So I is equal to 2 now. So is I less than 6? So our I is 2. Is 2 less than 6? Yes, it is true. So again, it will be incremented here, and we have to input another value. So inside our column 2, row 0, we have a 0 value. So next, since the condition is still true, as I will be incremented, is 3 less than 6. Is 3 less than 6? Yes, it is true. So we'll enter this one, and we'll have to input another value. So we have a 0 here. Then we'll proceed to I equal to 4, since I is incremented again, where 4 is less than 6. Is 4 less than 6? Yes, true. So we'll enter again, and we'll have another value. So inside our column 4 and row 0, we have value of 0. So next, so that I'll increment again. The program will increment again our I, wherein I now is 5. So is 5 less than 6? Yes, it is true. So we'll enter this, and we'll input a value. So I have input 4 here. So inside our column 5 and row 0, column 5 and row 0, I have value of 4. So again, it will increment. So our I now is equal to 6. So is 6 less than 6? So now our condition is false. So what will happen if we enter this? It will exit from this loop and proceed to our inner loop, wherein j will be incremented. So our j now will become 1. So here, since j is incremented, our j is equal to 1 already, and it will go back again in this condition where I is equal to 0 again. So I is equal to 0. So let's enter this. So notice that we have already here 0 and 1, wherein we are now in our column 0 and in our row 1. Since here, in our %d, it represents that it will present the first %d will present the value of our I, and the second %d will get the value of our j. So now let us enter our value in column 0 and row 1. So I will input, let's say we'll input 0. So again, since here I is 0, we'll increment it. So I now will become 1. So is 1 less than 6? Yes, it is true. So now we'll enter this code, our program, and then it will ask again for us to input another value. So just put 0 again. So let me just put our values here to our table. So in column 0 and row 1 we have 0, and in column 1 and row 1 we have 0 again. And then now we'll input here our value. Since I again will be incremented, so I now is 2, and then it will ask for us our value. Then I'll input 6. So inside our column 2 and row 1 we have value of 6. So again, I will be incremented, where I will now become 3, and let's go back to this condition. If I is incremented, then it will is 3 less than 6? Yes, it is less than 6. So if we enter this one, then it will ask for another value. Then I'll input 0. Then inside our column 3 and row 1 we have column 3 and row 1 will have 0 again. And again, I will be incremented, where I is equal to 4 now. So is I less than 6? Is 4 less than 6? Yes, it is true. So we'll enter this one. Since it is true here, we have now our I equal to 4 and j equal to 1 here. So we'll input another value here. So let me just copy it inside our table. So for column 4 and row 1, I have a value of 8. So again, I will be incremented where I now is equal to 5, and we'll have this condition. Is I less than 6? Is 5 less than 6? Yes, it is less than 6. So if we enter this, notice that we have here 5 and 1, our condition. So I have put 0 as our value inside. So next, I again will be incremented where I is equal to 6 now, and is 6 less than 6? So it is already false. So what will happen again if we enter this is that it will exit from this loop and it will go back to our inner loop. Here, this is our inner loop where j is equal to 2 already, since rj lately was 1, so now rj will become 2 as it will be incremented. So if we enter now, notice that we have already 0 and 2, where after we enter this inner condition, it will go inside the second condition where I is equal to 0 now, and as I have said, j is equal to 2. So you'll notice that it is, our I here is 0 and our j is 2. So it means that we are now in our column 0 and row 2. So let's have a value here. I'll input 0 again. So since I have already input 0, I will be incremented again where I will be equal to 1. Since 1 is less than 6, it will ask for our another value here. So I'll input 0. Then I again will be incremented since it is still true to our condition here. Then it will ask for another value 0, and then if I enter this, since I will be incremented again, I is equal to 3 now, and then notice that if we enter this, it is now in our column 3 and row 2. So we'll have to input another value here. So I again will be incremented where I is equal to 4 already. So is 4 less than 6? Yes, it is true. So it will again increment. So let's have another value here. So I again will be incremented where I is equal to 5 now. So is 5 less than 6? Yes, it is true. So we'll have to enter again since the condition is still true. So we'll input 0 as our value. So let me just input these values here inside our table, wherein in column 0 and row 2 we have a value of 0, and in column 1 and row 2 we have another 0 value, and then in column 2 and row 2 we have a 0 value again, and here in column 3 and row 2, column 3 and row 2 we have 10, and in column 4 and column 2 row 2 we have 0, and in column 5 and row 2 we have 0 again. So let's increment again our I. So I now is equal to 6. So is 6 less than 6? No. So our condition now is false again. It will exit from this loop and will go back to this inner loop where j is incremented. So j will become 3, and I, as j is incremented, it will get inside to this condition where I again is equal to 0. So notice that if we enter this, our I here is equal to 0, 0, and our j is equal to 3. Okay? So in this part of our code, this prints our array values. So we have created this for loop to implement or present the arrays inside. So it can be seen here that in our column 1, here in our column 1, we have these values, and in our column 2, we have these values, and in our column 3, we have these values, and our column 4, we have these values, and in column 5, we have these values, and column 6, column 7, and column 8. So that's it. So now in our sparse matrix here, this is the code for our sparse matrix. These are our sparse matrix where we have the non-zero values as presented. So lastly, in our program, we have the triples or the three row table where we have column, row, and value. Since we already removed the zero elements and it's here, we can see that in our column 0 we have 2 as our value, and in our column 5 and row 0 we have 4 as our value, and in column 2 and row 1 we have 6 as our value, and in column 4 and row 1 we have 8 as our value, and in column 3 and row 2 we have 10 as our value, and then column 0 again, and in row 3 we have 12 as our value, and column 2 and row 3 we have 14, and column 4 and row 3 we have 16, and column 2 and row 4 we have 18, and in column 3 and row 4 we have 20 as our value, and column 1 and row 5 we have 22 as our value, and in column 5 and row 6 we have 24 as our value, and column 1 and row 7 we have 27 as our value. Since the implementation of this code or the sparse matrix is a column major, you'll notice that here our column is not orderly mannered, wherein you can notice here that in our row it is from the lowest to highest, and here we can see our values. So that's it for our sparse matrix. After performing this activity, I have come to understand that sparse matrix has a majority elements of zeros, and the storage of sparse matrix has only non-zero elements that can be stored in a triple table wherein we have the row, column, and value. As to implementation of this sparse matrix, we can implement or represent sparse matrix through using an arrays or linked list representations. So using sparse matrix can save a lot of computational time in performing operations on the matrix. Since we only store non-zero elements, it saves us a lot of memory or space. That's all. Thank you.